Hi friends, this is Mohammed Jibran and welcome to our C++ tutorials. In this video, I'll be explaining you how to implement queue using an array. So, what is a queue? Well, actually, as you know, queue is a line of persons standing in any kind of line, like a theater line or a ticket line. So, the person who enters first will go out of that line first, and the person who enters last will go out of that line last. Like this line, this person has entered this line at the first position, so he will be leaving this line at the first position. After this lady will leave, then this gentleman, then this boy, then this, and this boy who is at the last position will leave this line after all has left. So the queues work on the principle of first in, first out. So this guy was first to this line and he'll leave first, and this guy is last to the line, so this will leave this line at the last. So this is how our queue looks in a C++ program. It has a front end and it has a back end. So back end is also known as rear, and this is known as front. So front is from where your line begins, and rear or back is where your line ends. So the first element in your queue, this queue, will be 100, second is 200, likewise last will be 500. So this is your queue. So now let us see how to use queue and how a queue works. Suppose you have a queue of 4 persons: Sue, Bob, Joe and Meg, and your queue begins from front. So your Sue is at the first position in your queue. After Sue, Bob is there, then Joe, then Meg. Meg is the last in the queue, so she is our rear end. So when you want to add something to a queue, the new element, or in this case the new person, should occupy this empty space. So whoever comes out, who wants to join this line, he should comes and occupy this last empty space. So suppose there is another person known as Ken. He joins the queue, so he should take the vacant place of here, and then Sue leaves the queue. The first person over here is leaving the queue, so the front end, the deletion will be done at the front end. So she'll go out and Ken will come over here. So see, after Meg, Ken is over here, right? So now our rear end is, our queue ends at Ken, not at Meg, because we got one more person at the last of the queue. So now as Sue has been removed, so the Bob will come and occupy the first space, then Joe will come the second, Meg third, Ken fourth. Now let's see, Bob has been placed in the first place, and then Joe, then Meg, then Ken. So if now Bob leaves, Joe will come and takes his place, Meg will take Joe's place, and Ken will take Meg's place. If anybody else comes, then your line again keeps on filling these elements. Okay, so this is how a queue works. Now let us see how a program works in a queue. Suppose you have 4 elements, an array of 4 elements. At initial, the value of front will be 0, as you can see, your line begins from here, and the rear should be -1. Okay, because your queue or your array is empty at the moment, so it should have the value -1, which means your array is empty at that instance of time. And then you are using the insert function to insert the value of 3, so it should be getting added at the 0th position, because your front value is 0. So your 0 will come and get stored at the 0th position. Now your front is 0 and your rear is also 0, because your line begins at 3 and ends at 3, because you got no any other element in the array. So then again, if you insert one more element, that is 1, so now the next element will be inserted after the 1, because your rear has been incremented from 0 to 1. Like here, when your queue was empty, rear has had a value of -1. When one element was inserted, your rear was incremented by one number. -1 plus 1 will give you 0. Okay, then one more element was inserted, then the rear was again incremented by one number. So 0 plus 1 will be 1. So now the value will be inserted at the rear end. So you insert one more element, suppose you insert 5, your real value will get incremented by 2, and that's the place where your next value will be stored. Your 5 will be stored over here. If you want to store again 8, your real value will get incremented by 1, it will go 3, and here you can save the 8 number, because your real value is 3, so you are saving that number on the third location. Now this was about the insert function, and now if you want to remove an element from the array, so when you remove an element, the first element, as it is first in first out FIFO, the first element which you inserted, that is 3 in this list, will be removed. So what will happen is your front value will decrement and it will come over here, it will increment and it will come to 1. Just like your rear value, your front value will also increment whenever you delete. Whenever you add, your rear value should increment, and whenever you delete, your front value should increment. Like this. See, you deleted one element, your front value incremented by 1, and your rear value is still 1, like this, because your last element is at the first position, and now the first element is also at the first position. So your front and rear values are 1 and 1. Now after that we are inserting again one more element, that will be 7. So as your front is 1, now the rear should get incremented and the value will be stored at the number 2 location. Like this, your front is 1 because your first element is stored at the first location and your last element is stored at the second location. So your rear value should be 2. Again, if you call the remove function, your first value or your front value will be removed again, because of it is a FIFO, first in first out. So first is removed, again your rear is incremented and your front stays the same. Okay, then you are again inserting a value of 0, then your front stays the same because your front value is again the same, it has not been changed. Your rear value gets incremented. Okay, like this 3, because your last element is at the third location, so your rear value will be 3, and your first element is at the second location, so your front value will be 2. So this is how queue works. So now let us write a program to use it. Okay, now let's begin our program. We'll first change the name of our class, let's say queue, and in our class I'll need a variable, say queue. Let's give it the max size of 500, so it will take maximum 500 elements. Okay, then I'll need one more, it's rear and front. This will work as our rear and front of our class. Now in our public section I'm going to define a constructor. Okay, now your rear should be equal to front should be equal to -1. Okay, writing this is as similar as writing this. Okay, so nothing makes a difference, but I'll go with this one. Okay, front equal to rear equal to -1. So whenever your object is created, the value of front and rear will be -1 because they don't have any value in it, so the values should be -1. Okay, then after that what I'll do, will create a insert function. Insert function. Okay, then the return type of it will be void1, and we are going to take some arguments from the user. So this will be the element which the user wants to enter in your array. So in that we are going to First check if our array is full or not. We'll check if rear is greater than 500. Okay, that's our last number. We are not taking any number above than that. So if it is greater than 500, we'll say the queue is full. Okay, so this is what we'll say, and we'll again say front and the rear will be equal to -1 because they are full. When they are full, their value is -1, and when they are empty, the value will be -1. If it is not full, then what it should do, it will add in our queue line. What it should do, it should increment our rear value. That's what we saw in our image. Whenever an element is inserted, your rear value gets incremented by 1. So what I am doing, I am incrementing this plus means 1 plus rear value. Rear value in your first case, when your program is initialized, is -1 because here we have given rear equal to -1. So here it is -1 plus 1 will be 0. So the first element, whichever is coming from the user, will be stored in the 0th position of our array. So now let's move forward to X. Okay, then after that we'll take the value as X. Okay, we are saving this value in the rear of X. Cout will say successfully inserted. What you inserted? You insert the value which is in X. Okay, so this was our insert function. And now let's move on to some other functions like delete. Void delete. Okay, now don't use delete. Okay, don't use this thing because it's an keyword, so your compiler might give an error. So use del or something else, don't use delete. So in that, I'm going to check if our queue is empty or not. If it is empty, then you cannot delete any value from it. If it is not, then you can delete. So this is how am I checking my queue. If front is equal to rear, whatever the value will be, -1, 0, 2, if they are equal, so your queue is empty, so you cannot delete anything. So you should say the queue is empty. Okay, this is what I'm going to say, and when it is empty, it should return back. Okay, now if it is not empty, then I'll say that successfully deleted. What I deleted? I deleted QL. I'm going to increment our front. Okay, so let us see again what happened. Whenever we removed one element, our front value got incremented. See, front here was 0 and here it became 1, so front plus 1. Okay, now that's what we are doing, plus 1 front. Okay, we are incrementing the value of your front. Okay, when it is done, so our del function is completed. Now we'll go for display. Now this function will display all the elements in your queue. Okay, so how it will display? Again, we have to check if your queue is empty or not. Front equal to rear. Okay, if your queue is empty, then it should say, let's copy and paste it, no need to write again and again. Let's see, Control V, done. If it is not empty, then I'm going to use a of your list. We are going to see out what Q, L, and which works on I. Okay, so now we'll give some space between each element. Okay, so now here I am declaring a variable, that's I, whose value is front plus 1, and who will be checking the condition which should be less than your rear value, and it will increment as our number changes and our list goes from 1 to 2, 2 to 3. So now we'll come to our main function. In our main function I need an integer, say ch, then I need an object to our class, say q, and we'll use a while loop which works on the values. Okay, now in the while loop what I'll give the options slash n, press 1 to insert, slash n, press 2 to delete, slash n, press 3 to display, slash n, press 4 to exit. Okay, we'll give them one more option, that's to exit the program. And whatever the values the user gives, we'll save that in ch. Okay, now after that we'll work on a switch case, ITCH. Okay, be careful with your spellings. Switch case will work on the value given by the user, and we are storing that in ch, so I'll write that over here. Then I'll say if the user presses 1, so what should it will do? It should say enter the MVNT element to insert. Okay, so when the user gives that value, we'll save that in ch. Okay, then we'll call a function that is q dot insert. Okay, which works on the value stored in ch. Okay, this is how you insert a value, and after that we'll say break the statement. Then we'll go to the case 2. If they say presses 2, so it should delete, so we are going to call uu dot del. Okay, we are going to delete, break, right there. Now if the user presses 3, so what I need to do, I need to display dot, so I'm going to call the display function. Okay, now again break. So now we are done with 3. Now I need to give him the option of exiting. So we need one more header file for this, so let's add that also. Exit 0. Okay, it should get closed. So break, right, and will come out. We'll say get ch, and now it will return what? 0. Okay, so now let's add the header file which we need. Okay, let's first run it without that header file and see the error. See, we got the error. Okay, so now let's add that header file as Okay, so now let's run it again. Oh, what happened is q of I. Q is small, it's not capital. Okay, now when you run it, has no function named exit. Okay, don't do it like this. Exit is to work on like this. Okay, now your program should work. Yes, it works fine. So let us press 1 to insert, enter the element to insert. Say we'll add insert number 11, successfully inserted number 11. Again we'll say press 1, we'll insert number 23, successfully inserted 23. Again we'll press 1, now we'll add 45, right? So now we'll see display 3, 11, 23, 45. So now we'll say delete. Now we'll say display 23, 45. See, when we said display for the first time, it said 11, 23, 45 are there in your queue, but now it said 23 and 45 because 11 was added at the first number. So now it has been removed at the first number, as FIFO works, first in first out. He came first, he went out first. So now if you again add press number 2, your 23 will be removed. Now display 45. If you again say delete, again say display, the queue is empty. Your queue is empty, so it cannot display, delete anything. So now let's press 4, program exits. So this was a program which works on stack using arrays. If you know the program which we created for stack using arrays, then you can understand this program for stack using for queue using arrays. Both the programs are exactly the same. You just need to understand. If you understood only any one of the program, you can do the second program. The difference is there we added and removed everything from the same thing at the back, but in the queue we have two things, that's one is front and one is rear. So we do everything on two places, that's front and the rear. As your image showed, we had two things, that's rear and the front. So hope you understood the program, and thanks for watching the program.